They were, but they're like really smart programmers.
This morning they had me breakfast on the page.
You would never give yourself an assignment.
So there's a math.random that you can use, and it'll generate a double between 0 and 1. But then you can do whatever you want with it. So if you want a number from 0 to 100, multiply it by 100. If you want an integer, cast it to an int. If you want something from minus 50 to 50, generate a number from 0 to 100 and subtract 50. And then you're back to doing graphics.
I see that people have used it. I've seen you use it.
If you
How do you know if you can cast something onto something else?
So-
Did you read the truncation?
Regex is already.
Oh yeah, right.
Especially with int and double.
Yeah, so casting is a general idea. Suppose you have double x and integer y, and you do x divided by y. So there's a general notion in Java that it will convert things to maintain precision. So if you have a double and you're dividing by an integer, it will convert this y to a double, and then do double divided by double, right? So if double x was equal to 1 and integer y was equal to 3, this will be equal to 0.33333. But if you did integer x equals 1, integer y equals 3, and you do x over y, that's an integer over an integer. It considers that valid. It'll give you a 0. It'll give you an integer result. So if you wanted to force this to do doubles, right, you could do something like double x. And even though x is an integer, it converts it into an equivalent double value. So you could do that. And if you wanted to be totally clear, you could divide by double y. And now that's certainly going to give you 1/3, 0.33333.
What if y is a character one and it's character and it's a 1?
And you try to cast it as an int,
Yeah.
it'll tell you it can't.
It won't. Okay.
Yeah. So you can use integer dot parse int or something like that. And if this is a double and I try to cast it as an integer, it'll at least complain about loss of precision. I don't know if it'll actually let you do it or not, but it will at least warn you that you're doing something funny. All right, so there's some question you wanted answered on the midterm. Which one?
It was the AZ one.
AZ.
Yeah.
You know.
There was more than one of us that read that as the beginning.
Right there.
Was it
Oh, this
maybe?
one.
Oh, it is beginning. Read my lives.
To write a main method that uses a scanner class to read words.
Oh, no, you
Count the number of words that begin with an uppercase A or lowercase z.
Jesse read that as begins with an uppercase
Yeah,
A and
or
ends
ends
with a
with
lowercase
a-
z.
yeah.
Oh,
Which would have been more interesting.
that would be harder to do.
Yeah. Well, I mean, if you use the string linked one
Yeah,
and then -1.
yeah, that's harder.
Yeah. Yeah, it is hard.
As opposed to just character at 0.
Man, don't give them any ideas.
For the final, I'll add
It sounds like a next quarter thing.
Yeah.
Yeah, next quarter.
You can do that for the next round of.
Okay, well, if you did ends with, I'll cut you a break.
Is there a method for just grabbing the last character in a word?
What he said.
And you can't use there's not a fancy built-in way to do it.
String length that -1.
Yeah,
Inside of character.
so
Oh, that is fancy.
string
I was
character
really
at.
fancy. I made it way harder.
Right, the caveat being if your string has a length of 0, this will throw an exception. So you got to check for that.
You have to use a try except block.
No, don't use that. Use an if statement. Right, so if length is equal to 0, then do whatever is appropriate. Otherwise, use this. Or cast this to something, or not cast, but interrogate or something like that. Or you could reverse it and then do character at 0, because I think there's a reverse method.
Oh, really?
I think so.
We'd reverse.
It's like reverse character.
Oh, I couldn't get back.
Oh, that would be.
I think skaters just call that
Reverse the word and then index the first character.
Design a program to read this backwards.
Or you could do a regular expression.
There's a starts with method, but no ends with method. Is that what you use?
Oh, there is no reverse. Yeah. Or regular expression, like $, would match the last character. and
Well, you
throw
can
it into
also-
a register.
You also do a for loop, and then you're subtracting instead of by
Yeah.
by
Or you could open a URL and
Can you
ask your friend, here's a string, what's the last letter you see?
button the phone a friend button.
Yeah.
Convert it to a char
That'll be
array or
Skype.
reverse
Is
order.
regex easy with is it built
Oh, I
in?
know
Is
there
it
is
something
an
that's-
Regex is easy. Let's talk about regex next week because it's a good thing to do. You basically create a regular expression and you build what's called a pattern out of it. So you compile that into a pattern and then you can say, does this string match this pattern? And you can pull pieces off into different
It's the
registers
same.
and so on.
It's the same style as.
Yeah, same regular expression style.
Dude, how do you change your working hours?
Yeah, that's good. Let me go ahead and make myself a note.
Okay, so every time I make a new project, it's creating stuff that it's more path that I don't want.
Well, in the beginning, for me, it every time I open Java, it says where do you want it?
Yes.
So when I was doing PA3, I had a button that I shrunk down and the text didn't fit, like it ran off and did dot,
Mhm.
dot, dot. So I was trying to figure out how to get a new line. So on the button, you just jump down. And people online were saying to put just HTML in there
Ooh.
to get it to word route, and it worked.
Really? So you can put HTML in button text?
Yeah. So I was
That's
just
pretty cool.
wondering if,
So
Is that just a J button?
yeah,
Wow, I didn't realize that.
I did like the angle bracket HTML and then angle P, typed out what I wanted to say, and then did the HTML thing where you do the slash,
Mm-hmm.
repeat what you just did.
I wonder if you could use that to link it to something, like some site.
Oh my god. Yeah, I could play my tic-tac-toe
It's
game,
like,
I
yeah,
swear.
like,
It's clean.
Totally personality.
Oh yeah, can you also go over how to make it an executable file?
Yeah.
That's important.
Oh yeah, the jar.
That's cool. I didn't realize you could put HTML in there. That's nice.
Yeah, I thought I might have to like import something, but it just, it worked.
Yeah. There's a lot of horsepower behind these things.
I hated the Eclipse at the start of PA3, and now I've pretty much loaded it.
Cool.
same, yeah.
It's amazing to know hit the play button and know it's gonna do something.
Yeah,
as opposed to
yeah.
do a something
Although I
else.
hate how like sometimes you'll lose something like the debugger thing. Like I lost it wouldn't debug because my individual variables were all gone. It was just showing you a bunch of threads.
That shouldn't happen.
Figure out how to get that back.
I never even tried to put it into debug perspective.
I prefer you say this to
Yeah, that's the
Oh, really? That might be a bug.
What's wrong with it?
Yeah.
I have my Google Drive set up.
So if you want to make an executable from your Java code, open your project, right-click, say export, and then down here under Java, say runnable jar file. And that'll jar file will just give you a Java archive, but if you make it runnable, you can click on it, or say java-jar, name of the file, and it'll go ahead and execute it. And you need to specify obviously where you want to put it. And then you need to tell it what the name of the main class is that you want to execute. And I can't do that here because I've got 80 billion main classes in here, and most of them are called main. But if you took my advice and only had a few projects in each one, right, then you can put in the name of the class there.
Test 1, test 2.
Yeah, exactly.
Test. Not a test.
Not a
Real
test.
Real test.
Yep.
Fake test.
Yeah.
Testing our test.
It's exactly how you do program numbers.
Yeah.
Final version. The final version.
Yep.
The real final.
Just kidding, this is the final one.
Best final. Final dash keep.
Penultimate final.
All right. So other questions? PA3 okay?
I'm kind of in the middle of it still, so I'm not sure.
Okay.
I got it so that it actually paints accurately, like I can put multiple shapes on now.
Cool.
So now I just need to focus on drawing.
Gameplay.
Yeah.
Okay. Awesome.
think on there it said something about like have a reset button or something
Mm-hmm.
when the game ends. Does that need to like pop up, like appear,
It's up to you.
or it can just be there?
It can just be there as long as you don't let the user like reset the game halfway through when they're about to lose, right? So be stateful, right? So you can gray it out if you want, or make it completely disappear, or you can just ignore it if it gets clicked while the game's already in progress or whatever.
I had it disappear, but that took me a little while
Yeah.
to learn.
That's cool. Yeah, you can set the visibility on most components, so you can just set visible true or false, and it'll just gone. Yeah.
Can that be the same button as the button you click to start the first game?
Yes.
Okay.
So you could click that to start, and
You can even change
it
the
doesn't
text
do
at the
anything
end
until the
of it.
game ends, and then when you click it, you start a new game. Yeah, that's good.
Can we make a rage quit button so if we get really
Yeah.
And have it do nothing. Have it do nothing.
Yeah.
or let the computer take another turn.
Right.
say, sorry, you can't quit just because you're losing.
Or have it flash in big red
The
letters.
X in the corner.
Wow, that's true.
Yeah. Now you can capture that too.
Okay.
Yeah.
So every time I try to
Just
quit,
Jumanji
it's
style. You don't
Yeah,
have to
yeah.
wait until the game is over.
Yep.
If you wanted like a pop-up window to happen
Mhm.
upon something, would you have to have like another JFrame class?
You could do it with another JFrame. Yeah, just create it and set it visible,
Mhm.
and you can see in the main program that's created for you how to do that. You might want to position it also. Set its XY coordinates, but yeah, you can just create it on the fly and make it visible, or you can create it, I think, in the design window and just not make it visible until you want to see it. But if you wanted to pop up, 80 windows, right, you just create them on the fly. All right, any other questions on PA or midterm? I don't know if I'll get through the midterm by tomorrow, probably not. But sometime in the next few days I'll get it graded. All right, let's talk about PA4, because it's that time of year already. Yeah.
We're also gonna talk about lab.
Lab 4 is a week off, so I believe.
Oh, it's not next Friday?
It's next Friday.
Oh, it isn't. I'm
Yeah.
talking about it on Monday.
I'll talk about it on Monday. So let's talk about PA4. So PA4, we're writing another game. We're going to play 20 questions. Okay? And you're writing a program which will basically guess what you're thinking of by asking you yes/no questions. Okay, so, and how many people have played this before? Right, so it's a fairly common game. You can buy little plastic gizmos that'll do this for you, and they're remarkably good. You think of some obscure thing, and within a few tries, it says, you're thinking of a pink flamingo. It's like, whoa. Right? So how does this work? We can play 20 questions by using what's called a decision tree. And it's like a binary tree, but it's not a search tree. Well, it is in some way, but it's not ordered like a search tree. So here's a real simple decision tree. Here's a real simple decision tree to figure out what it is you're thinking of. Okay, so I ask you to think, I'm the program, I ask you to think of any object in the universe, real or imaginary, and to tell me when you've got an idea in your head. Okay, so you say, okay, I'm thinking of an object, you hit enter, you hit a button or something like that. And I ask my first question, and every node of this tree is a question until we get to the leaves. So my first question is the thing you're thinking of something that's hard? And if the answer is yes, then I follow my tree to the left. And if the answer is no, I follow the tree to the right. So somebody think of an object. Who wants to volunteer their brain? Okay, so think of an object. Okay, is it hard?
Yes.
Yes, okay, I know what you're thinking of. It must be a rock. Was I right? Okay, good. So if you were thinking of a rock, right, I'm a genius. Computers smarter than humans, right? But I say, okay, I know what you're thinking of. It's a rock. And you say, no. Okay. So now we say, what were you thinking of?
Marker.
A marker, okay. So you're thinking of a marker. So I'm going to change this to a question. And I'm going to say, tell me a question I could have asked that differentiates a marker from a rock.
Can you write with it?
Can you write with it? Okay, so my new question is, can you write with it? And if the answer is yes, then what were you thinking of? Marker or a rock? Marker, okay, so if the answer is yes, it's a marker. And then if the answer is no, obviously, you were thinking of a rock. Okay, now we can play the game again. Think of something, and somebody says, I'm thinking of something hard. And instead of just saying, you must be thinking of a rock, I say, can you write with it? And you say, yes. And then I say, okay, it must be a marker. Yes, you were right. Amazing. Right? Or no, you can't write with it. Okay, I know you were thinking of a rock. Okay?
So this thing is going to learn each time.
And it's going to learn the more you play with it.
But it only learns during the instance of it being open, right?
Yes.
So once it closes, it goes back to thinking rock or pillow.
No, you're going to save all of this.
Oh.
So the more you play it, the better it's going to get.
That's cool.
Oh,
Yeah.
So it's AI.
So it's AI. So this is a decision tree, right? Every node other than the leaf nodes are questions. The leaf nodes are answers. And to traverse the tree, we ask the question at the root, and we go left or right depending on whether the answer to that question is yes or no. Okay? And when you get to a leaf, you announce your answer, and if it's correct, you don't have to do anything, right? You correctly guessed what the person was thinking of. If it's incorrect, get a new question. Put that question in place of the answer that was wrong. And then one of those directions, the yes direction, takes you to what they were actually thinking of, and the no direction takes you to what you had mistakenly guessed. Okay? So,
Does that mean we're going to be manipulating a text file?
so you're going to be manipulating a tree, and the tree is going to get saved in a text file. And let me say this up front, but we'll stress this again as we get into details, right? It's not a good strategy to try to manipulate this text file directly. Okay, you want to do all your work on this tree, and when you're done, you want to write this into a text file in a very particular way that makes it easy to read it back out of the text file. Okay? If you try to go directly into your text file and do what we did here, change this to a question and add more nodes, it gets really confusing. Okay, and there's no need for that. Logically, it's a whole lot easier to modify the tree and then say, okay, here's my new tree, write it to a text file. And then when you begin the game for the first time, go to the text file and say, pull in the data from there, build a decision tree from it. Okay, do that in the beginning and the end, do your modifications in here. All right, that's the basic setup. Let's look at some details. See if there's anything here. So we're not restricting you to 20 questions. You play until you get to an answer. But how many different objects can we store if we actually let the person ask up to 20 questions? Over 1 million. 20 questions means that basically we have 20 nodes between the root and the leaf.
Tree of height 20.
So it's a tree of height 20, and your tree's number of nodes is roughly 2 to the height. So 2 to the 20th, the order of 1 million questions, 1 million leaf nodes, right? So we can store a lot of information and filter it out just with 20 questions. That's why 20 is a good magic number. Because 1 million items, I don't know if we know more than 1 million items each. I don't know what that number would be. It's an interesting.
Are we restricted to like nouns? So you want to say like, what are you thinking of in general?
You could do anything that you can parse with yes/no questions. So you could say, you know, I'm thinking of a song lyric. But I think you could be thinking of an action, right? So think of something you like to do after taking an exam.
Oh, and that would be just another question, like is it an
Yeah,
action?
so it could be, is it violent, you know, or
Yeah.
does it involve destruction of property, or does it purify your soul?
Yes.
Yes.
A rock.
Obviously a rock.
Does it hurt?
Yeah.
No, it's
Definitely
fire.
a rock.
I feel like this is how they got that chatbot going.
Yeah.
They corrupted it really fast.
Are
Yeah,
we
yeah.
are we gonna be using a built class already for trees, or we're creating our own tree?
You're gonna create your own trees.
And then is there a class like position list and position node? We're gonna have tree and node. Or?
So you're basically going to need to define what a node is, okay? And it's basically going to be a string that holds either a question or an answer. It can be useful to put a flag in there that says, is this a question or an answer? But if you don't have any children, then you know that it's an answer. If you have any children, you're going to have two children because you have a yes and a no direction. And that's about all you need in a node. And then the tree is really just a root, which is a first node, and you just follow it down left or right. So there's no particular traversing, there's no general searching or inserting or deleting, right? It's really just this adjustment we make when we get to the end. And we'll do the details of that in a bit. So begin at the root, which is a question, ask the question. Based on the response, if it's yes, go to the left. If it's no, go to the right, until you can't go down any further. At that point, you've got an answer. Tell the user what your guess is.
Are we only doing like inanimate objects or like
No, you can do whatever you like.
animals?
Yep. Although it's nice if you sort of tell the user up front, right? Think of an animal or think of a place or something like that.
Or the first question would just be, is
But-
it living?
Yeah, so I mean, you can just say, think of anything you want, you know, and it's just going to take a few more questions, like, is it living, is it real, is it fictitious, that kind of thing. So if the answer is correct, no action is necessary. If the answer is wrong, ask for a new question, and the best way to do this is something like, so, is it a rock? No. What were you thinking of? A marker. Okay. Please tell me a question for which the answer is yes for a marker and no for a rock, or something like that, right? You can take the guessed answer that was wrong and the correct answer and turn it into a sentence that says, basically, tell me a question so that yes will take me to the marker, no will take me to the rock. And then you know whatever question they give you can go here, marker goes on yes, rock goes on no. And it doesn't matter if you do that or you switch them, but you can direct the user to specify the question however you like, in a way that works for your algorithm. All right, so the initial decision tree is read from a file, and it's going to be a whole lot easier if you don't start with an empty file. If you start with a bare minimum file, like is it hard, yes it's a rock, no it's a pillow, right? Then you don't have to worry about the edge cases where you have an empty tree, for example. So it simplifies your life a little. And in your submission, you're going to have a string called database, and it's just going to have the name of this file, right, and use that. So that if I want to test this with a different decision tree file, I can just change the value of that one string, and it'll run with a different decision tree. All right, that's a detail. Make sure your code is well commented. And you have a lot of artistic liberty in this assignment as well, okay? So you can do this strictly from the command line, and if you're struggling with Eclipse or Window Builder or things like that, right, you can go back to straight command line with this. You don't need a lot of fancy imports. You can do this on the Linux server and compile it there, or you can do it in your favorite Java environment and just print something out, user types yes or no or Y or N and plays the game like that. That's perfectly fine. But if you like Swing and you like Window Builder and you want to get fancy, you can make it all graphical. You can have buttons for yes and no and a text window and something that counts the number of guesses and have fun with it, right? Let yourself go as crazy as you like. So I will post this as soon as I set it up for this class. I actually got a lead for this assignment from a former student who went to UW, and they were doing something similar, and they had a database that had been crowdsourced. And I think I called it 20Q Big. So I'll make this available sometime in the next few days. This is a big database of 40,000 lines, okay, so roughly 20,000 questions or answers. That works well with the algorithm we're defining.
Is that what our text file is going to be?
That's what your text file is going to look like, and we'll talk about the details in a minute. So, yeah, so there's,
Boy, someone thinks of nothing.
yeah.
They're 2% of the way there.
They didn't do that right.
2%.
Yeah.
Is it It sure is.
Shape-shifting.
It's on
Does it swallow fish by flicking back its
A
head?
shape-shifting alkaline?
Yeah.
This is full.
So this is a crazy database.
Double apostrophe.
Alright, so
Yeah.
It's very specific.
Does it carry
Maybe
babies
so the legend goes.
Stork.
So
Is it a bird?
yeah. So there's a lot of stuff in here, and it's
Arrow tongue.
yeah.
We have to do ours absolutely from scratch.
Did Predator bring it from outer space?
Are you going to say no every time? Apparently, it's say nothing.
This is a good one. Is it a very, 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 very cute, tiny, cute horse?
That was going to be your last answer. Are you going to say no every time?
Yeah. So you're going to start with your own, 3-entry decision tree file, right? And as you play the game, it's going to build that file up. But you are welcome to swap question answer files with other people, right? Which is a good check on your formatting and make sure that if 3 of you have files that work with each other's code, you're probably all doing it right as opposed to all doing it wrong in exactly the same way. So it's a good second check on that. But then you can also change that database string and point to this file, which I'll probably put under /temp on the Linux server. And then you can run against this and play 20 questions with that, and also augment it if you manage to stump it. It's pretty hard to stump, actually, if you play it honestly. It does a pretty darn good job of guessing, but it's crowdsourced, so it's got noise in there, right? And sometimes you go down a path and it's like someone was just being goofy.
One answer was all I got, just click all yeses.
Yes.
And maybe it's the Papa Smurf spelled.
Yeah.
Lowercase p,
Yes.
uppercase b.
Right,
Do
right.
you have a sample of this that you could run with that?
I just tried it and it was throwing an exception. I have no idea why. I think it's because I'm on Linux and I must be doing something goofy. But we'll run through a demo on Monday, definitely. All right, let's talk about this decision tree file. So here's a sample decision tree we're working with. Is it an animal? And if yes, then it's a pig, and if no, then it's a rock. I know. I couldn't remember a pig, so I used pillow, but I knew there was a rock in there somewhere. Yeah. Anybody here ever have a pet rock?
I've seen
Besides me? Yeah. It was the thing to do.
So it's a question followed by the right answer followed by the wrong answer?
Not necessarily.
Just want to ask more questions.
Question followed by.
Oh yeah, because then you might replace
So
rock
if
with.
someone's thinking of The Thing or Dwayne Johnson, you kind of win right away, don't you?
Yes.
Real quick.
All right, so here's the file that corresponds to this tree. So the general setup is, it looks like we have, so it's always a Q or an A followed by the actual question or answer. Okay, didn't have to be like that. It just simplifies your life a little easier because you don't have to split up lines. So you read something, and if it's a Q, you know this is a question. If it's an A, you know this is an answer. Okay, here's the whole trick to writing this file from a tree. Traverse the tree in node left right order. Okay, if you do it in that particular way, the rest of this becomes pretty easy. So you want to traverse node left right. That's different from our usual binary search tree of left node right. So pre-order. So if we traverse this, first we visit the node, and this is a question, so we would write out a Q and then say, is it an animal? Then we go to the left. There's no children, we know this is an answer, so we write an A followed by the answer. And then we traverse to the right, there's no children, so it's an answer A, and we write out that answer. Okay, is it an animal? Yes. Is it a pig? No, I was thinking of a dog. Okay, so let's have a new question. Does it bark? And if yes, it's a dog, and if no, it's a pig. Okay, so you got the information from the user, you've updated your decision tree in memory, write it out to your file, okay? So we're just gonna rewrite the original file using node left right traversal. So node, first we start with a question. Is it an animal? And then we want to traverse the left subtree. So here's the left subtree. Visit the node first. So, yeah, this is on 2 lines. So the root is a question, does it bark? And then we go to the left, and that's an answer, is a dog. And then we go to the right, that's an answer, and it's a pig. So we visited the node, we visited the left subtree, now we traverse the right subtree. That's an answer, and it's a rock. Okay, so it's not immediately clear from looking at this file that this is the corresponding tree. Okay, because the answers to does it bark are here, but the answer to is it an animal, the no answer is way down here, right? But since we know this is node left right, it's pretty easy to build this tree by reading this file. And it's a nice recursive algorithm. So let's see if I can get this right first try. Sometimes that happens, sometimes not. So read the first 2 lines. We could think of it logically as 1 line, a question or an answer. Read the first 2 lines of the file. That's the question, is it an animal? Okay. If it's a question, set it as the root of a new tree. So we're going to have a tree whose root is it an animal? And then we want to basically read whatever tree is specified in the file from this point down and make that the left child of this node. So let's do something a little pseudocode-ish. So let's make something called ingest. You could pass it a scanner if you want, or you can make the scanner global or something. But the purpose of ingest is read a decision tree from the file. And this is going to return a decision tree, which is just a tree, right? So how does this work? Read first 2 lines. If it's an answer, return a single node. So if we're at this point in our input file and we read the first 2 lines and it says a dog, dog is an answer, we're going to build a tree with a single node which is a dog, and we're going to return that as the decision tree from ingest. Okay, otherwise, we're going to say temp, we're going to say root, root equals the question we just read. And then we're going to say root.left equals ingest, and root.right equals ingest, and return root. And unless I made some boneheaded mistake, this is going to be all you need to do to read in from a file. And it's recursive, right? We're making this function ingest, but we're going to use ingest. But here's the idea. We're going to start off, we're going to read the first two lines. It's a question, is it an animal? Okay, if it was an answer, we just return whatever that answer was, but it's not. So we're going to set the root of a tree to be the question, is it an animal? So, is it an animal? That's the root of the tree we're going to return. And now we're going to call ingest again. So we're in a recursive call to ingest, which starts here, reads the first two lines of the file, and it says, does it bark? That's a question. So this call to ingest is creating, and let me switch colors here. We're in this call to ingest. So we're going to create a tree, and the root of that tree is going to be, does it bark? And then that's going to cause a call to ingest. And so it's going to say, read the first two lines of the file, which will be this answer dog. And since it's an answer, that call to ingest is just going to return the node containing dog. And we're going to set this root.left to be dog. And then we're going to call ingest again. It's going to read these two lines. The answer is a pig. So it's going to return a node, which is just pig, and it's going to say, set the right child of this root to be a pig. And then we're going to return the root. So this call to ingest here, this first call, is going to return all of this. And this line of code said, take the root's left child and set it to whatever ingest gave you back, which is this tree. And then it's going to say, call ingest again. And ingest will say, read the next two lines of the file. That's an answer is a rock. It'll return a single node containing just a rock. And this line says, set the right child of the root to be that answer. And then we're returning from our original call to ingest, so we're done ingesting. We're also out of things in the file, which should always happen. And the tree that was returned by that call to ingest is the decision tree we're after. Right, so is it an animal, does it bark, dog or pig, and a rock. So this takes some playing with on a piece of paper or a whiteboard to convince yourself what's going on. But once you convince yourself that this is the right thing to do, right, then you can code it up like this faithfully and not have to think too deeply about what's going on in here, right? And there's this split you can make when you're doing things like this with data structures. At one point you want to understand what you're doing and why it works, but then when you're actually coding it, you don't want to be burdened by trying to sort of understand, wait a minute, so what's this going to do at this point? Is this right? If you want to think about it at that level, sometimes it's useful to step outside the code and go back to pictures or pseudocode or something like that. And then once you feel like this is the right pseudocode, then go ahead and write the Java code for that, right? And then start testing it.
To understand recursive functions, you must first understand recursive functions.
Exactly.
So ideally, if there are no children in the node, it's an answer.
Mm-hmm. Right, when you're going through, if there's no children, it's an answer. If it's a question, it's going to have two children.
I mean, like if the game hasn't been played enough on that particular file, there might only be one answer on something.
Yes.
So.
Yeah. But like I say, if you start off with a file, it always has one question and two answers. It keeps you away from edge cases. And yeah, so that's an easy starting point. All right, so think about this, kick it around. We'll finish PA3, think about this, kick it around. We can talk about it more on Monday. We'll go through a sample of executing this on Monday. I'll post the 20Q big file on /temp on the Linux server, and we can go from there. Yeah, this is a fun assignment, I think. It's